Welcome to trigonometry. Today is our first lesson in trigonometry. This is right angle, right triangle trigonometry. Hang on to your boots, guys. This one is my favorite. I've got all kinds of fun things to do, so we're going to be working on this for a while now. Okay. Right triangle trig. We're going to be doing a lot of rational expressions, a lot of fractions, so you have to get really comfortable with them. So, to solve this first equation for x, we're going to, a couple of ways we can do this, but we multiply both sides by the base 24, and that's going to leave x all by itself. So I have 5 times 24 over 8. Well, let's see. 24 is 3 times 8. So I can get rid of the 8. I have 5 times 3. So x is 15. Doesn't look like you can simplify this. The problem is we've got a square root in the denominator, so we have to rationalize this. So I'm going to end up with root 2 over 2. This is important because we will be expressing our sines and cosines in radical form. All right, find the length of the hypotenuse of a right triangle whose legs measure 4 and 6 centimeters. Well, this one we're going to be using our Pythagorean. Okay, so that's merely 4 squared plus 6 squared equals c squared. 4 squared is 16. 6 squared is 36. 16 and 36 is 52. So that's my c squared. I square root both sides. Okay. Now we take the square root of both sides. 52, is 26. So it's 2 root 13. That's my hypotenuse. Okay. Moving along. Trig is the algebra of triangles. A right triangle trigonometry is based on the ratio of the sides of a right triangle. This is how we define our sines and cosines and tangents and cotangents and all of them. The angles of a triangle can be named using their vertices, usually capital letters. Lowercase letters, such as A, B, and C, are representing the side lengths opposite the angle. So if angle A is here, side A is there. Angle B, side B. Angle C, side C. So generally speaking, if we're labeling it A, B, and C in this fashion, C is our right angle, and so side C is our hypotenuse. They can also be named by Greek letters. So sometimes we have alpha, beta, gamma, and theta. All right, so that's also possible. AB with this line over it is used to represent a side, while AB refers to the side's length. This is the physical side. This is the length of the side. Okay, that's some of our vocabulary. We're doing a lot of different stuff, so you need to know what we're referring to. In a right triangle, the side opposite the right angle is the hypotenuse. So in these cases, 10 and 15 are your hypotenuse. The other two sides are legs. 6 and 8 are legs. 9 and 12 are legs. The side opposite angle A, this is going to be little a. This one would be little w. The side opposite angle B, so this would be little b. This would be small x. And then my hypotenuse, In this case would be little y, and this one would be little c. Okay, ratios of corresponding sides within similar triangles are equal. These triangles are similar because if I take the side lengths of A, B, and C, of ABC, multiply them by, 3/2, I get the side lengths of WXY. Okay, so these are similar triangles. And that is also important for you to know. All right, so now we're going to talk about sine, cosine, and tangent. These are our three basic functions, trig functions: sine, cosine, tangent. Sine is the length of the leg opposite. Actually, you know what I'm going to do? I'm going to make that into a highlighter. Boom, boom, boom. Opposite over the hypotenuse. Cosine is adjacent over hypotenuse, the length of the leg adjacent to the angle, right? So that means if I'm looking at this angle here, the leg adjacent would be this side. And this is really weird to do with highlighter. So let's do it with a line. Okay. So if I'm looking at this angle, the side adjacent would be here, the side opposite is this one, and this is my hypotenuse. So both of these two functions, the denominator is the hypotenuse. Cosine is the adjacent, and sine is the leg opposite. Okay, the way I look at this, to remember this, I use this as a bow and arrow right here. This is my thing, and I shoot an arrow, I'm going to hit the side opposite. I'm going to shoot and hit what's opposite me. Adjacent is the one next to me. Okay, opposite and adjacent. Adjacent is not hypotenuse. Yes, the hypotenuse is next to me, but the adjacent is not the hypotenuse. The hypotenuse is the hypotenuse. Okay, so we have adjacent, opposite, and hypotenuse. Now notice for the tangent, we have the opposite over the adjacent. No hypotenuse in this one. Okay, so that's our tangent function. All right, so that's represented here. All right, this I find confusing. So what I want you to remember is not this. It's O over H. Opposite over hypotenuse. This is, we have a short term we use. So for sine, ka, toa. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. SOHCAHTOA. That's an acronym you can use to remember how to do these functions. SOHCAHTOA. SOHCAHTOA. Opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Okay, we also have reciprocal, not inverse, reciprocal. Inverse is different. We have reciprocal functions. We merely are flipping them. 1 over sine is cosecant. 1 over cosine is secant. 1 over tangent is cotan. We remember this function, and then we don't have to worry about all of this. It becomes obvious if you remember. You're just flipping your sine, cosine, and tangent. Okay. The other thing we recognize is, notice that S and C, C and S, T and C, the letters never match. That's important because you're going to look at cosecant and think you want it 1 over cosine. You don't. Letters never match. Okay? Tan, cotan are obvious, but cosecant, sine, secant, cosine, that's not as obvious. The letters never match. Okay, pound that into your head. The letters never match. All right, so what we do is I want you to memorize, and we're going to work mainly with sine, cosine, and tangent. But if you have to do the others, just remember, they're flipped. They're reciprocals. Okay, so Already we're at a lot of information, so we're going to be taking this, try to take this a little slowly. Okay, now, remember our SOHCAHTOA. All right, sine is opposite. Oh, I haven't shown you what theta is. Okay, we're going to call this theta. Okay, so the sine of theta is opposite 4 over the adjacent, which is 3. Nope, sorry. Over hypotenuse, which is 5. Cosine is adjacent over hypotenuse. Now notice, for sine and cosine, 5 is the same. So this is my little trick, okay? So you got to be careful. It's a trick, so you got to know when to use it. But notice, tangent is opposite over adjacent, so it's 4/3, right? Opposite over adjacent, 4/3. Okay, now, the only thing we have to remember at this point now is just we're going to flip all of these fractions. I'm going to rewrite that one that I just erased a little bit of. Okay, so we're going to flip all these fractions, and I'm going to have 5/4, 5/3, 3/4. Now, I always write mine out in this same pattern because it makes finding all those numbers super easy. All right, let's look at the next one. I'm going to zoom in a little bit. So sine, if we're going to take this as our theta, sine is opposite over the hypotenuse. Cosine is adjacent over the hypotenuse. All right, there's my adjacent. Whereas my tangent is opposite over adjacent. Now, for the reciprocal functions, I merely flip these. Also be aware, if I was had any square roots in there, I would have to rationalize. All right, and that's that slide. That was number 8. This is number 9. Okay, we're just going to be refamiliarized with the Pythagorean theorem. We're going to use it a lot. A squared plus b squared equals c squared. This is a little graphic that shows you that. If I took and I counted out A, notice this is 4 by 4. It's a box, 4 by 4. So I have 16 units. So I have 1, 2, 3, 4, and then I have 4 rows. Okay, so this then represents A. B, on the other hand, is b squared is 9. So I have 1, 2, actually, let's use a different color. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Whoa, see? They all match together. So a squared plus b squared is equal to c squared. Okay? All right. I apologize. I have bad allergies, so I'm a little sniffly. All right, example 2, state the exact values of the 6 trig functions of the angle H. Okay, so this is our angle. So I need to find out what little h is because I need all the sides. So I can use my Pythagorean theorem. This is my hypotenuse. In other words, C, if I'm using my Pythagorean theorem. So I have 1 squared I'm trying to make it bigger so I can show you better. 1 squared plus h squared equals 2 squared. So that's 1 and 4. So h squared equals 4 minus 1, or 3. So h is the square root of 3. Okay. All right, we're going to move on to the next slide. Get the 6 trig functions. Here they are. I wrote them out for you in the order. I want you to get used to that. It is by far the easiest. Trust me, I've done this for many years. All right, so sine, we're looking at h here. Okay, so the sine is the opposite over the hypotenuse. Hypotenuse is 2 in this case. So h is root 3 over 2. That's my sine. Cosine is adjacent, which in this case is the 1. It's never my hypotenuse, over the hypotenuse. And my tangent is my opposite, which is root 3, over my adjacent, which is 1. Well, this is not a sufficient answer. Over 1 just means the number, so what I really want to answer for this one is root 3. Okay, so I'm going to... Okay, so these are my 3 answers. Now, to do the other 3, super easy, just flip them. So now I have 2 over root 3. Well, I need to rationalize that, so it's going to be 2 root 3 over 3. Secant is 2 over 1, so that's 2. And tan is back to 1 over root 3. I have to rationalize, so it's going to be root 3 over 3. Okay, so those are my 6 answers to this question. All right. Hopefully you're getting a feel of it. If one trig ratio of an angle is... in a right triangle is known, the other trigonometric ratios can be determined using the Pythagorean theorem and reciprocals. I'll demonstrate. Trigonometric ratios for specific angle measures were traditionally found in tables, but now you have your calculator, and you will be allowed to use your calculator. Now, you have to understand that that's if I'm looking for a rounded answer. If I want an exact answer, you leave me in numbers. I don't need a decimal. Okay. All right. Now, this is the other important thing for this lesson. A degree can be divided into smaller units. There are 60 minutes in a degree. So just like an hour, there are 60 minutes in a degree. It is written with that apostrophe. Single apostrophe means minutes. So 83 degrees, 15 minutes. Minutes can be further divided into 60 seconds. So there's 60 seconds in a minute. It's denoted by the double apostrophe, quote marks, 36 degrees, 40 minutes, 20 seconds. Okay, that's just defining down closer the size of the angle. You should recognize these because this is used in GPS. All right, now to convert 36 degrees, 40 minutes, and 20 seconds to decimal degree, you're going to take, it's 36, and then you have to divide 40 because there's 60 minutes in a degree. We divide it by 60. Because there are 2 sets of 60s, I divide by 60 squared for my seconds. Now this actually is 3600, so you can divide by that or 36 or 60 squared, your choice. But 60 squared in your calculator works, and I think it's easier to remember. So what this would be, if I put this in my calculator, all right, I have 36 plus 40 divide 60 plus 20 divide 60 caret 2. Enter, I get 36.6722. Okay, now going the other way. We're converting decimal degrees into minutes and seconds. So what I do is, first off, I strip off everything above the decimal. That 83 is my number of degrees. Then I take the decimal that's left and I multiply that by 60. So 0.48 times 60, and I get 28.8. Well, My minutes, I strip off the fractional part. So my minutes would actually be 28. But I take that 0.8, you can see in the next line, multiply it by 60 to get my seconds. And I have 48. And that wasn't working. There we go. 48 seconds. So this is minutes and this is seconds. So my answer would be 83 degrees, 28 minutes, 48 seconds. That's how you do this, because you're going to have to do that in your homework. So you need to know how to do it. You're going to do it on the test. All right. Also, so a lot of this is in your formula sheets. You need to be keeping track of these things in your formula sheet. All right. Given an acute angle, alpha, that is, the tangent of alpha is 0.6. Find the other 5 trig ratios. Well, we know that 0.6 is 6 over 10, which simplifies to 3 over 5. We also know that the tangent is opposite over adjacent. So I'm going to draw a triangle, and I'm just going to label the sides. I pick an angle, so I'm going to pick this angle. And then I get opposite is 3, and opposite over adjacent. Adjacent is 5. Now I can use my Pythagorean theorem to find C. Now I have all 3 sides of the triangle, so I can find all of my angles. Okay? So the sine of alpha is opposite over hypotenuse. Well, I'm going to rationalize. So it's going to be 3 root 34. Well, let's make this a little prettier. Okay, it's going to be 3 root 34 over 34. My cosine is going to have the same problem, so it's going to be 5 root 34 over 34. Now, you're welcome to go ahead and put these in decimals if you like. Cosecant, I'm merely flipping it. It's going to be the square root of 34 over 3, square root of 34 over 5, and this was 3 over 5, so now it's 5 over 3. And I have all 6 of them. It's really not that hard. Okay, review this video more if you need to. Okay, so now you're going to put this in your calculator. Find the secant of 83.25 degrees. First, check to make sure you're in degree mode. To do that, you hit mode. All right, that's up there next to the second button. Right next to the second button near the top of your calculator is the word mode. Above it says quit. Okay, you type mode. You go down, it should be the 3rd line. And it has radians or degrees. Whichever one is being surrounded by a black box is what's highlighted. So you go over to degree and hit enter just to be sure. Now it should be highlighted by a black box. Now you're in degree mode, and so you can find your reciprocal of the cosine. Okay? So what that means is what you really want is 1 over the cosine of 83.25. You don't need to include the degree symbol since you're telling it already ahead of time it's in degree mode. So you don't have to deal with that. So it's going to be 1 divided by the cosine of 83.25. And that should give you 8.5. For trig functions, we usually use 4 decimals. So it's going to be 8.5079. Okay, so that's how you use it on your calculator. All right, and we are done. So you're going to read sections 10.1. That's what we've just gone over. Read over it. Make sure you understand it. Do your homework, and once you've had your homework done, I want you to go online and do the homework quiz. There's a little 3-question quickie quiz that I want you to do, And all it does is make sure that you have done your homework and you've done it all by yourself and you're understanding it. So let me know if you have any problems. All right.